and they are separated by some distance r. So this is q1, q2, right? So Coulomb says that the force between these two charges will be q1, q2 by r square, right? And and if you place this in a medium, right? If you place all these charges in a medium, so then the force will decrease by a factor of one over k, right? If you place this in a medium, so the force will be F air by k, where k is your dielectric constant. Let's say this is F, right? Oh. And and then you have this equilibrium law, right? That it says that whenever the sum of all the forces is zero, then that charge will be said to be in equilibrium. Okay, so so there are two kinds of equilibrium. Okay, one equilibrium is that, let's say these are two charges, right? And you place some other charges in between them, right? So that the forces acting off from this side, let's say this is F1, and forces which is repelling this charge in this direction, F2. So this point, force F net is zero, right? So then this charge will be at equilibrium. So this is the equilibrium of one point, right? But there is another second kind of equilibrium, which is called the system equilibrium of systems, right? Equilibrium of a system of charges. So this tells that so when you calculate, so this charge, let's say this charge and this charge. So this is one point, this is second point, and this is third point. So whenever this happens, that all the forces from here, F net is zero, right? And in here, F net is also zero. And in here, the F net is also zero, right? Then this will be called the system of the charges are in equilibrium. Okay. So in Coulomb's law, there are some combinations. So Coulomb's law is combined with the equilibrium. And then there are some other forces, let's say tensions, and let's say that if you join the two charges between two springs, then you have restoring forces. Or if you put the charges in some liquid, right? So then you have some buoyancy involved. So the Coulomb's law is then combined with some mechanics, right? Coulomb's law plus equilibrium. So these are the type of questions that they ask. And Coulomb law plus some mechanics, right? And these mechanics can be of, let's say, tension, due to tension, and this can be of due to some, let's say, spring, or you place some liquid, so this would be buoyancy, right? So in this class, we would be studying all these combinations. Okay. So we will start with a very basic question, and then we will gradually upgrade our questions. Okay. So let us start. I will be more focusing on the problem solving part, right? I will be more focusing on the questions that I have. So let's do this first very simple question, right? Okay.
Sir, can you just scroll up?
Yes, sorry. Were you noting down this part?
We don't have to note.
Yes, you don't have to, right? So
Okay.
you already learned this in your CBSE syllabus, right? I'll be more focusing on the
Sir.
questions. Yes, so this simple question, right? Two free point charges plus Q and plus 4Q are at a distance L apart, right? So two charges and they are, so this is, let's say plus Q and this is plus 4Q, right? And they are L centimeter or L, what is that? Let's say L unit apart, okay? And so a third charge is so placed that the entire system is in equilibrium, right? So a third charge is placed, let's say at some distance, x, right? We have to calculate this distance x, and then we have to calculate the charge on this. So what kind of charge we should put that all these systems are in equilibrium, right? So first question would be that what would be the polarity of that charge that we should put? Okay, let's say if you put a positive charge, okay, positive charge, then what will happen? So at this point, so let's divide this as 1 point, this is second point, and this is third point, right? So at this point, you have force due to this charge, right? And at this point, at this point, we have force due to this charge again. Okay, so this will push this in this direction. So this is F4Q, and this will push this in this direction. So this is F2, right? So these are in opposite directions. So this will be in the equilibrium. But what will happen to this charge? So this at this point, at one position, the force will be acting in this direction, right? So this would be due to FQ, and the force would be again repelling in this direction. So this is 4Q, right? So this can't be in equilibrium, right? Right, guys?
Sir, can I once again explain the diagram?
Okay, yes. So let's say if I put a positive Q charge, okay, right?
Yes, sir.
So then what will happen? Then we would calculate the F net at this point, F net at this point, F net at this point, right? So for the system of the charges to be in equilibrium, all this F net should be 0, right?
Yes.
So at this point, there would be this force, right? Force due to this charge and force due to this charge. So this will repel in this direction, right? And this will repel in this direction, right? So this is looking like at equilibrium, right? But at this
Yes.
position, the forces due to this Q will be repelling this side, right? And this 4Q also will repel in this side. So this can't be in equilibrium, right? Right,
Because the
Chavez?
related Q will also repel in this direction.
Right. So this, yes, the positive Q will repel in this direction, and this plus 4Q will also repel in this direction, right?
Sir.
So this will be not in equilibrium. So we should change the polarity of, let's say what happens when the polarity of this charge is negative, right? So let's say that polarity is negative. Okay. Then what will happen that this will attract. So this will force will be attractive. This will attract in this direction, right? And this pole will attract this in this direction. So this would be, let me erase this part. So this would be due to 4Q, right? And this would be due to Q, right? So this is looking like at equilibrium. Okay, so this second point is at equilibrium, right? And what about this first point? So at first point, this will attract in this direction. So this would be FQ, right? And this will repel in this direction. So this would be 4Q. Now you see that this is in the equilibrium, right? Right, guys. Any question from this diagram? No question, I guess. Okay. So
No,
let
sir.
us, yes. So let us calculate the equilibrium from this second point, right? So from this point, we know that FQ is F4Q, right? So in calculating the equilibrium, we don't consider the sign of this charge, right? We have,
Sir, equilibrium
so
means at every point force will be zero.
Yes, at every point F net is zero, which means that the force which is in the left direction is equal to the force in the right direction, right? Right, Chavez?
Yes, sir.
Yes. So let us calculate FQ. So FQ would be how much? This would be KQQ by X squared, right? And F at 4Q would be K4Q, right? And Q and upon L minus X squared, right? So this guy cancels, K cancels, and we have what? So this is first question would be simple, right? And then we will upgrade the level of those questions. So this would be how much? 1 by X square is 4 by L minus X square, right? So let us take this guy here. So this is 4x square, and take the square root in both the sides. So L minus X is plus minus 2x, right? So if we take minus 2x first, so this would be what? L minus X is minus 2x. So L is minus 2x plus X. So this is minus X, right? So X is minus L, which can't be true, right? X can't be minus. And then you have the second condition, L minus X is plus 2x, right? So L is X plus X, 3x. So X would be how much? L by 3, right? So this is the place where we should place this minus Q charge so that it is in equilibrium. So this X is L by 3, right? Now we will use the equilibrium at this point. We have to calculate the magnitude of this charge, right? We have to calculate the magnitude of this charge. Okay. So you guys first note down this part, and then, right? So you guys note this down, and then I will do the next one. Okay. So if you guys finish with noting down, then tell, you can tell, and I'll be going. Okay. Yes, everybody noted
Yes, sir.
this. What about everyone? Chavez, Nadia, Shahid, and what? And the rest.
Yes, sir.
Chavez. Yes. So then we will use the equilibrium. So we know the value of X now, right? X is L by 3. And now we have to calculate what is the magnitude of this Q, right? We know the polarity is negative, right? So let us erase this part, and Yes, so at this point, we know that FQ is F4Q, right? So how much is FQ? FQ is KQQ by how much? So this is KQQ by X squared, right? And how much is F4Q? This is K4Q into Q by how much? This length is L squared, right? So this guy cancels, and this guy cancels, and Q would be how much? 4Q and X squared by L squared, right? So we know the value of X, which is L, so 4Q and X square, L square by 9 into L square. Right, so this would be Q would be 4Q plus 2. So this is the magnitude of the charge that we should put, which will make all these system of charges in equilibrium. Right? Any doubt about this question, guys?
No, sir.
Okay. So please note this down, and then we will do the second question.
So, sir, here at every point charge will see whether the force is in opposite direction to make it
Yes,
equilibrium.
because that's why we can make it in equilibrium, right?
Okay.
That's how we can make it in equilibrium. Because if the forces are in the same direction, that will add up, right?
Yes, sir.
Yes, so everybody noted.
Yes, sir.
Yes, so let's tweak this question a little bit. And yes, so everybody knows about the Hooke's law, right? Okay, let me erase this, or let me put this question in there. Yes, so let me put it here. Okay, so we know already about the Hooke's law, right? So for the periodic motion or for the oscillatory motion, right, force is how much? Force is directly proportional to minus x, right? It goes against the direction of the motion, right? Against the displacement.
Spring, right?
Right, so this is Hooke's law. Yes, in spring, in pendulum, these kind of forces are in, right? So for the periodic motion, for the oscillatory motion, this is the force, right? Where this is the spring's constant. Right, so your acceleration is how much? This is minus k, and A is minus k by m x, and k by m is omega square, so this is minus omega square, where omega is the angular frequency, right? Right, guys, so you guys know this much? Okay, so in this question, what they have done is that, so firstly, the charges were in the equilibrium, right? So one charge, a particle of mass 1 gram, and charge q is lying at the midpoint of two stationary particles kept at distance 2 meters when each is carrying same charge as q, right? So this is q, and at the middle, so the distance between them is 2 meters, right? And so this distance is 1 meter, this distance is 1 meter, and at the middle, 1 milligram of charge, right? So mass is 1 milligram, right? This charge, and charge is q, right? So this is at equilibrium. Okay. Now what they did, that they displaces this q charge with some distance x, right? So if this is moved, then the force will change. F net will change, right? So this will no longer will be at equilibrium. Okay, right? So they want us to prove that this shows an SHM, simple harmonic motion, right? And also we have to calculate the angular frequency of the oscillation. Okay, so first we have to prove that this is an SHM, right? For this condition only, when your X is very less than, very much less than this length L. Okay. So now first we have to prove that your force is behaves like SHM, right? Force is directly proportional to this quantity, right? And then we have to calculate W, right? So did you guys understand this question?
Sir, here particles are
Yes. Yes,
two
Shah.
particles are Q charges.
Yes. So only this point is at equilibrium, right? Not this one, right? You already know that this polarity has to be negative for all the charges to be at equilibrium. So they are saying that this point is at equilibrium. Okay. So we have to calculate the force at this point only, right?
Yes.
Right, Chavez?
Yes, sir.
Yes. So let us calculate the force at this point. Right. So this is displaced by X. So this is how much distance? This is 1 plus X. Right. And this is how much? This is 1 minus X. Right, guys? This is Q. This is Q. This is Q. Right. So F net would be how much? For this part, for this charge, force will be in this direction. Right. What should I name this? F1. Okay. And for this charge, force will be in this direction, F2, right? So F net would be how much? So F1 I hat plus, so let's take this as magnitude, right? F1 I hat and F2 minus I, right? So the magnitude would be how much? F net would be F1 minus F. Right, any doubt in this part, guys? Let's say this is 1, this is 2. Okay. So how much would be F1? So F1 is K Q Q by distance is how much? This is the distance, right? 1 plus X squared, right? And F2 is how much? One minus X squared.
1 minus X.
Correct, Charles. Yes. Yes. So, and what is our goal? What is our goal, guys? Our goal is to prove that this F net is like this, right? That is how we can say that the force is oscillatory, right?
Yes.
So, yes, so we have to keep that in. So let us calculate the force. So this would be KQ squared, 1 plus X squared, right? And this is KQ squared, 1 minus X squared. Right, so when we will take the LCM, so this would be 1 square minus X square and then whole square. Right, and this so take KQ square form. Right, so this would be 1 minus X square and this would be minus of 1 plus X square. Right, guys. So this would be how much? KQ square, and this is 1 minus 2x plus X square. And this is minus 1 plus minus 2x minus of x square, right? And upon 1 minus x square by whole square, right? So this cancels, and we have how much? So this is kq square minus 4x divided by 1 minus x square whole square, right? This is f naught, right? Now
Yes,
let
sir.
us, yes, Shavas. Yes, Shavas, did you say anything?
No, sir.
Yes. So and we have to use this condition, right? So this distance x is very less than 1 meter, right? So let's say if you have 10,000, right? And if you have 1, so 10,000 square and plus 1 square or minus 1 square. So we can neglect this part, right? So that would be 10,000 square. So similarly, in here we can neglect this part, right? So then your F net is how much? This is minus 4kq square x, right? Is this looking like minus kx? Let's say kx, right? So this is looking like minus kx, okay?
Yes, sir.
And then we can write F net as MA, and this is minus 4kq square by x, right? So this is A is minus 4kq square x, and we can write, so this is looking like the simple harmonic motion, so we can write A as minus omega square x, right? So minus cancels, right? X cancels, and omega is root m comes here, right? M omega square x. So okay, so this is m, right? Okay, so this would be 4kq square by m, right? And k is how much? K is 9 into 10 to the power 9, right? Q square is given. Q square is how much? Q square is 10 Coulomb square, right? So Q square is 10 Coulomb square, right? And mass is 1 milligram, right? So this is how much? This is 10 to the power minus 3 gram, right? Which is 10 to the power minus 3, 10 to the power minus 3 kg. So this is 10 to the power minus 6 kg, right? So this is 10 to the power minus 6. So minus 6 and 10. So this goes and becomes positive. So this is 4 into 9 into 10 to the power 16. Right. 4 into 9 is 2 into 3 into 10 to the power 8. So this is 6 into 10 to the power 8. Right. And in the question, you can see that they have given this, the frequency of oscillation will be dash into 10 to the power 5. Right. So this is 6,000 into 10 to the power 5. So dash is how much? Yes, so the answer is 6,000. Right. Any doubt in this question, guys? So this is how Coulomb's law is combined with some mechanics. Okay, guys. So where should I put the screen? Where should I put the screen, guys?
Yes, sir.
Yes, sir. Here.
Okay. So I should write small and all in aligned way, right? Because I take too much of page. So I should write in a more proper way. Sorry about that, guys. Yes, so should I scroll down the screen?
So you can just
Yes. Oh,
How did we cut X square here?
yes, so you see that I gave an example, right? So let's say if you have 10,000 square, right? And minus 1 square, right? So this is a very big number, right? This would be something like 10,000 and then again 540 and again 40, right? And then minus 1. So this would be nearly equal to this quantity, right? So if this quantity is very small, so we can neglect that, right? So in the question, this is written that x is very, very less than 1, right? So this quantity is very big, right, with respect to this. So similarly, if we neglect that, so we can neglect this, right? Is it clear now?
Yes, sir.
Yes, so should I scroll down the screen?
yes, sir.
Now the next question will be your assignment. So you guys please do that and send to the operations team and then I can check, right? Yes. Ah, okay. Sorry. Sorry, Shahid. So is that okay?
Yes, sir.
So the next question is a very similar question, right? And you guys should try that. Okay. So try that and send me the solutions. I will check. Right, you guys have one whole week to solve it. Okay. Yeah, so should I scroll down this?
Yes, sir.
Done, everybody? Okay, everybody done?
Yes, sir. Going to finish.
Yes, Shahid, done?
Yes, sir. Done.
Yes, so take the screenshot of this question, right? And take it as your own. Right, so in this question, what they do is that, so in the previous question, what did we do? In the previous question, we, so the charge was here and we displaced in this direction, right? So the charge came here. Now in this question, take the screenshot of this question, okay? So in this question, what they do is that they displace the charge in this direction, okay? So the charge was here and they displaces this in this direction, right? So you recall the vector property, right? Let's say this is theta, so this is theta, this is theta, right? This is theta. So which component will survive, right? So you calculate the individual forces and which component will survive, you tell, right? And then you calculate what is F. And then you try to prove that this F net is minus kx, right? And then you calculate what? Yes, so then you calculate the angle. Right, so this is the similar question, right? Only you have to see which component survive, right? And then you add that component, okay? So this is x distance and this is d distance, right? So you guys take this as your homework and so did you guys take the screenshot of this question? Everybody took the screenshot? Everybody, yes or no? Why guys, you guys?
Yes,
Yes,
sir.
sir.
Yes, yes, yes. Okay, so now the next type of combination is in the Coulomb's law is with some mechanics, right? You guys have already learned about the free body diagrams, right? So in the next set of questions, you will learn about the tensions, right? So the charges are hanged with some string, right? With some massless string, and it has some mass, right? So there would be a tension acting in this direction, right? Yes, Chavez.
No, sir. Nothing.
Yes. So the tension will act in this direction. This direction will have mg, right? And if there is some charge in some, let's say here, so there would be some forces, right? Cool. So these type of charges which are based on Coulomb's law, right? And then equilibrium. And then you have tension, right? So we will discuss about this type of question. Okay. So let us see the first question. Okay, so in this question, yes. So these charges are at equilibrium, right? This plus Q and this plus Q are at equilibrium. This yellow strings are some strings, right? And these charges are repelling each other, right? This distance up to this point is R. Okay, what happened? Yes. So this distance is r. Okay. And in this question, they want us to find the magnitude of this charge. So we have to find Q is what, right? So we have to focus on this part only, right? This charge, and we have to calculate, we have to use what we have learned in your 11th class. So the most important thing in your 11th class, FBT, right? So we will use FBT and we will use the we will calculate this charge. Okay. So let us, what are all the forces that are acting on this charge? So first
Restraint
is,
for tension.
yes, correct, Shravan. So tension in this direction, right? So you see that this is acting with some angle, right? So this is theta. So this would be theta, right? Parallel. So alternate interior angles, right? So this is tension, right? As Chavez said, and this is some angle. So this tension will have two components, right? So this would be how much?
T cos theta.
Yes. So this is how vectors are important, right? And this is how much? This is T sine, right? And then this has some mass M. So this would have the weight, right? Force due to gravity. So this is M, right? And these charges are repelling each other, right? So this will have F Coulomb in this direction, right? Do we have another kind of forces? No, right?
Yes.
So let us draw the free body diagram. So this is mg, right? This is t cos theta. This is t sine theta. And this is Coulomb force, right? And all these are in equilibrium, right? So t sine theta would be, so I should write in the problem. So t sine theta is F Coulomb, right? And t cos theta is mg, right? So let us divide this two. So tan theta would be how much? Tan theta would be Fc by mg, right? So your Fc would be how much? Fc is mg tan theta, right, guys? And what about the magnitude of this Fc, right? So Fc would be kq, so kq square, and distance is how much? So this is r plus r 2r square, right? Which is mg tan theta. And we have to calculate this q, right? So, and so this is kq square by 4r square, and this is mg tan theta, right? So your q square is how much? Mg tan theta by k, and then 4r square, right? And let us look here. So this is r, right? This is theta, right? And this is L. So this is P, right? This is P, this is H, and this is theta. So which trigonometric ratio relates P with H? Sine theta, right?
Sin theta.
Correct, Travis. So sine theta is R by L, right? So R is L sine theta. So this would be how much? So this is, and Q is 1 by 4 pi epsilon naught. So this is 4 pi epsilon naught mg tan theta and 4 and L square sine square theta. Right, so this is Q is root 16 pi epsilon naught and mg tan theta and L square sine square. Right, so this is the answer. Okay, any doubt in this question, guys? We just use the equilibrium, the Coulomb's law, and the tension, right? So
Here in question, we cannot express this magnitude in terms of R or like that.
yes, we can express in terms of R if R is given, right? So if R is given
Yes.
some value, then we can write the value on, right? But if R is not given, so we have to write which, because we know always the length of this string, right? Length of this string is known and theta is known. So we can write in terms of that, right, Chavez?
Okay, sir.
Yes, so where should I put the screen? This is okay, right? Right, guys? Okay, just note it down and then we will do the next question. So the next question is a similar kind of question, but they have asked some different things, right? So I'll be doing all the combination of question that they can ask from the Coulomb's law, right? So that is my today's goal. Yes, only Chavez, Tarif, and Shahid, and what? So all other guys are silent. What about you guys? If you don't understand a thing, then you can ask, right? And if you have problem with something, then again you guys can ask, right? Okay, guys, noted. Yes, everybody noted. Am I audible to everyone?
Yes, sir. Doing.
Yes, so Chavez is done. And what about the rest of you guys? Okay, how many guys are?
Yes, sir. Done.
Yes, Tarif also done. Yes, there are 6 people. So 2 people done, 4 people.
Done, sir.
Yes, Nadia, yes. And Shahid, done.
Yes, sir. Done.
Okay. Yes, I guess everybody has written. So let us move on to the next question. Right. So the next question is a similar kind of question, right? But in this question, they have asked what is the equilibrium separation when each thread makes a small angle theta with the vertex, right? So the important information is that this angle theta is small, right? This is the important information, and we have to calculate the separation between the charges, right? Okay, so the diagram is similar, right? So the diagram is same. And we have to calculate this separation, right? So let's say this is D, so this is 2D, right? And this is L, this is theta, and this is Q, right? And this is again, right? So again, we will use the same funda, right? Tension is in this direction. This is the angle, right? So what would be the free body diagram? So let us draw the free body diagram in here, right? So this would be, so this has mg, this has t cos theta, this has t sin theta, and this has what, f, right? So again, t sin theta is fc, right? And t cos theta is how much, mg, right? And again, tan theta would be fc by mg, right? And we have to calculate the separation d. Okay, so 2D we have to calculate actually. Let's say this is d, right? This would be d by 2. Okay, this would be d by 2, this would be d by 2. Right, so we have to calculate d. So tan theta, and again recall, angle is very small, right? So for small angle, tan theta is nearly equal to sine theta. Right? Yes, tan theta is sine theta, which is theta, right? So sine theta would be how much? So this is d by 2, right? D by 2, and this is n. So sine theta would be p by h, right? So this is d by 2l, right? And this is fc, and this is n, right? So d would be how much? This would be 2l, fc is how much? Kq square by, again, d square, right? By mg. Right, so d would be 2l kq square by d square and mg. Right, so this would be how much? So this would be dq, which is 2l and by 4 pi epsilon naught, and this is mg, and this is q square, right? So 2 cancels, and we have d is lq square by 2 pi epsilon naught mg power 1, right? So this is the answer, right, guys? Which one is the correct one? So this one, q square l q pi epsilon naught mg, right, guys? So this was a similar kind of question, but they ask about the separation. And one important information was that the angle was very small. Theta was small, right?
Yes, sir.
Right. So if you guys note it down, then I can, right. Okay, any doubt in this question? This was a similar kind of question from the previous question. Only they have asked some different things. Yes, so everybody noted. Yes, guys. Yes, everyone. Why? Why is so silent?
Yes, sir.
Yes, sir. Done.
Arif, Shave is done. What about others?
Done, sir.
Yes, Madhya also done. Faiza is not Shahid done. Okay. Yes, Shahid and Faiza.
Yes, sir.
Yes, Faiza done. Are you done?
Yes.
So Shahid is maybe Shahid is there. Shahid is there, but
Sir, done.
yes, Shahid. Okay, so let us complicate this question a little bit more, right? So now we have three charges, right? So now we have put three charges, okay? And then we want to calculate the magnitude of this cube, okay? So let us calculate that, right? Again, what we have to
Sir.
use? Yes, sir. Yes, Charles.
Can you fully display the equation? Like,
The question.
yes, sir.
This is the question, right? These are only the word parts, right?
Yeah, yes, no.
So the important question is here, right? The diagram tells all the wordings here, right? So that is why I only show the diagram. Right?
Okay.
Okay, so three charges, right? And they are hanged with some strings, and they are at equilibrium, right? And we have to calculate the magnitude of this cube. Okay, in terms of M, L, and G, right? So again, free body diagram, right? So now you guys tell me this would be the same, right? Oh. So this tension part would be the same, right? So this is theta, so T cos theta, right? This is T sine theta. Again, this mg part is C. Now, what about this? So let's say this is R, right? This is Y. Okay. So what about this Coulombic force? How many forces will be there?
Two.
Right, Chavez, correct. So there will be one force in this direction, right? And the other force in this direction again, right? Force due to this charge and force due to this charge, right? So let's say this is 1 and this is 2. Okay. Now let us calculate again what is. So T sine theta is F1 plus F, right? And T cos theta is mg. Right. So again, tan theta is how much? Tan theta is F1 plus F2 by mg. Right. So your F1 plus F2 is how much? This is mg tan. Right. Now what is F1? So F1 is distance is r, right? So kq square by r square. And for this part, F2 part, this distance is how much? 2r. So this is kq square by 4r square. Right. This is mg tan theta. Right. So let's take kq square common. Kq square by r square we can take common. Do I have space in this? So I have space, right? Okay. So kq square by r square is common. So this is 1 plus 1. Right. So this is mg tan theta. And this would be how much? Kq square by r square, 5 by 2. Right. So q square you want to calculate. This would be mg tan theta and 4 and then r square and then 5 and then q. Right. And again r is how much? So this is r, this is L, and this is theta. So again r is L sine theta. Right. So mg tan theta 4 into r is L square sine square. Right, r square is. And 5 and k is 4 pi sine. Right, so this would be 4 into 4, 16. Pi epsilon naught mg tan theta L square sine square theta, right, by 5 and root. So this is q. Okay, any doubt, guys? Any doubt, guys? Yes. Okay, any doubt? Anybody says, please, respond, sir. Yes, sure. Okay, so you guys note it down and okay, so from the next set of question, we'll be doing another combination with the coulombs, right? You guys all know buoyancy, right? Buoyancy and Archimedes principle. So this combination would be Coulomb's law plus some equilibrium and then some buoyancy, right? Yes, so should I scroll right? Yes, so guys, should I scroll right?
Yes, sir.
Yes. So guys, remember about the assignment, right? Please give me the assignment that I shared.
Sir, that question, right?
Yeah, that question when we put the displacement in the upward direction, right? In the y direction. You guys please try it, right? And I'm here, right? If you guys face any problem, then I'm here. Yes, so everybody noted.
Yes, sir.
Yes, yes. So Chavez or Shahid? Who will be? And what about today?
Noted.
Yes, done. Okay, what about rest of you guys? Done.
Yes, sir. Done.
Yes. Okay, so let us do the next set of question. And before we do that, let us recall what is buoyancy, right? So if we put something in some liquid, some mass in some liquid, right? So let's say this is some liquid, right? Okay, this is very glittery. Okay, this is some liquid, right? Sorry about that. Yes, so this is some liquid, right? And if we place some mass, right? So this will displace some water, right? Some water will be splashed out, right? And the amount of water which is displaced out, so that would be the volume occupied by this this mass, right? This is the Archimedes principle. So Archimedes principle. Right. So this states that so this weight of this thing would be how much? Weight of this mass would be the volume that it occupies, right? Into this density of this liquid, right? Density of this liquid into this density of this liquid into the gravity, right? Acceleration due to gravity. So this is weight which is displaced, right? And this acts in the upward direction. So this is the buoyancy force, right? So this is the buoyancy force that act in the upward direction, right? So the next set of question would be the combination of Coulomb's law, right? Plus the equilibrium and plus this buoyancy. Okay, buoyancy, right? So let us do some question based on this. Before I do that, this is maxima and minima. Right. So you guys know about maxima and minima, right? So let's say before we do this buoyancy, let us understand about the maxima and minima, right? So you have some graph, right? So let's say this is y, which is f of x, and this is x, and this is the graph, right? So this graph has 2 points, which is extreme, right? This point, which is extreme, and this point. So this point is the minima, right? And this point is called the maximum, right? This has the maximum value, right? This also has the maximum value. Let us, oh, sorry. Okay, so this has the maximum value and this has the minimum value, right? So this is about the maxima and minima. And what is the mathematical expression for maxima and minima? So let's say if we take f dash x equals to 0, so that will tell about the maxima and minima, right? So to calculate at which point, so let's say this is x1 and this is x2, right? So you can calculate x1 and x2 by putting the first derivative equals to 0. So whatever the point you will get, that will be your that is also called the critical points, but that will be your maximum and minimum, right? So that is the logic behind the maxima and minima, right? And also one thing is that you take the derivative with the x, right? To calculate the maximum and minima, which is dependent upon this x. So you calculate the derivative with respect to x, right? So this concept, so there is a question which is based on this concept, right? So let us do that question first, and then we will solve the buoyancy combination, right? Okay, I have only 8 minutes, so I wanted to do electric field, but yes. So what we can do, right? We will do electric field in the next class. Okay, so a certain charge Q is divided into two parts, Q and Q minus Q. How should the charge Q and Q be divided so that Q and Q minus Q placed at a certain distance apart experience maximum electrostatic repulsion, right? So this is maxima we have to calculate, right? And remember, this is the function Q, right? So in that diagram, f was the function of x, right? So in this diagram, Q is the function, right? And we know what is the force F. So these are the two charges, right? This is Q and this is Q minus Q, right? The separation is R. Okay, so we already know what is F. F is Q and Q minus Q by R squared. Okay. Right, guys? And we have to find the maximum. Right, so to find the maxima, we only have to do what? First derivative. So the first derivative, but we have to remember that we have to maximize this function with respect to Q, right? So we take the derivative with respect to Q. Right, guys? So K by R square, yes, yes. Anybody?
Okay.
So, yes, Chavez, did you say anything?
No,
Yes. So first we have to do the differentiation of this and keeping this one. So Q minus Q into Q differentiation is 1. And then differentiation of Q minus Q would be how much? Minus 1 into Q. Right. So this would be how much? K by R square and Q minus 2Q, right? And to calculate the maxima and minima points, we put this differentiation equals to 0, right? So K by R square Q minus 2Q is 0, right? So this can't be 0, so Q minus 2Q is 0. So your Q is 2Q. Right, so this is about the maxima and minima of points. Okay, this option is correct. Right, so this was a very small question. You guys just quickly note it down and then we will do the buoyancy question. Okay. Any doubt in this question, guys? Guys, be more interactive, right? Then we can have chill kind of class, right? Okay, I have only 4 minutes. You guys, yes, yes, Chavez, Chavez or Shahid? Yes.
No, sir, Tarif.
Tarif. Sorry, Tarif. Yes. Yes, Tarif has noted.
Sir, for derivating it, are we using nx n raised to minus 1 formula?
Yes, in taking the derivative, we are what?
Are we using the nx n raised to minus 1 formula?
Which formula? Which formula?
Nx raised to n minus 1.
And rest formula, which
No, sir, he is telling.
yes, Chavez, are you saying something?
He is saying that x raised to n when we are differentiating that formula.
Oh, sorry, Tarif. So we are using u dot v, right? D by dx of, yes. Yes. So yes, so sorry about that, Tarif. I couldn't understand properly, right? Yes, thank you, Chavez and Tarif, to making it more clear, right? So we used u dot v, right? And yes, so we used that part also. So x n is nx n minus 1, right? And so in calculating the product of the two functions, we do what? We take outside and do the derivative of the second one. And then we take second one and do the derivative of first, right? In any way you can do that, or you can take v and do the derivative of first and take u and take the derivative of second, right? So first I did that, right? And then I calculated d by dq of q, right? So this is q to the power 1, right? So that would be 1 only, right? So this is 1. And in calculating the differentiation of q minus q, so d by dq of q minus q, so this is constant, right? This is constant, this is the variable. So this becomes 0 and we have minus of dq by dq. So this is minus. So that's why I wrote minus. Is that clear? So this derivative and this derivative, right?
Yes, sir,
Keeping
clear.
the, yes, Tarif, clear?
Yes, sir.
Okay. So we have not any time to do the buoyancy. So we should, can we take one question and, okay, that will take time. So we'll try that in the next class. Because the classes are 1 week apart and we have to quickly understand all the kind of questions, right?
Yes.
Yes, so sorry about the guys that I was slow. I should have paced myself a little bit faster so that I could have. So I wanted to complete these questions, right? This one, and these, right? But what we can do, right? Right, guys, and this one also. So I wanted to do up to electric field, but time is the supreme thing, right? We cannot cross time.